All right, so let's continue on with number 19b. Again, we're supposed to find a lot. We're supposed to find the vertex, the axis of symmetry, the x and y intercepts, the shape of the graph, lots of things. So let's go in order. Let's first find the vertex. And the vertex, if your problem is in standard form, like not standard form, but all multiplied out like this one, then the best way to go is negative b over 2a to find your vertex. Okay, so that's going to be negative of a negative 2 over 2 times a negative 1. So it's going to give me a positive 2 in the numerator, negative 2 in the denominator, which gives me negative 1 for my x value. But I'm yet to find the y value, so I still have to do that. So to find the y value, I take my negative 1 and I plug it into the function. So that's negative of a negative 1 squared minus 2 times negative 1 plus 3. Now negative 1 squared is 1, but then this negative thrown in front of it makes that negative 1 plus 2 because of the two negatives plus 3. Negative 1 plus 2 is 1, 1 plus 3 is 4. So my vertex is negative 1, 4. My axis of symmetry in green is always x is equal to the x value of the vertex. So whatever this x value of the vertex is, that's what goes here. So that's my axis of symmetry. Okay, this is a parabola. How do I know? So it's a parabola shape because of the x squared. That's the giveaway right there. Okay. Now it's just to find the x-intercepts, the y-intercepts, open upward or downward. So let's do x-intercept next. So the x-intercept, that's the worst of all the calculations to me. You set y equal to 0 and solve. So I have 0 equals negative x squared minus 2x plus 3. Now you really shouldn't use the quadratic formula with a negative leading coefficient. So I'm going to multiply everything by negative 1. So 0 times negative 1 is 0. Negative x squared times negative 1 is positive x squared. Negative 2x times negative 1 is plus 2x. And 3 times negative 1 is negative 3. Notice all the signs changed. Now, if I could find numbers that multiply to be negative 3 and add to be 2, then I could factor. And you know what? We can. So that's going to be a plus 3 and a minus 1. Notice positive 3 times negative 1 multiplies to be negative 3. Positive 3 plus negative 1 adds to be 2. So I have x plus 3 equals 0 and x minus 1 equals 0, which is going to give me two separate x-intercepts. Okay? Subtract the 3, add the 1. These don't go together, y'all. This is the point negative 3, 0, and the other x-intercept is 1, 0. Okay, there's my x-intercepts. Y-intercept, do this in pink, you set, so the y-intercept, you set x equal to 0. Okay, so that's the easier one because you say y equals negative 0 squared minus 2 times 0 plus 3. Y'all, that's just 3. So y equals 3 in point form. That's the point 0, 3. Does this graph open upward or downward? You know what? This guy opens downward. How do I know? Whenever the leading coefficient is negative. Our leading coefficient is negative 1, so it opens downward. Now, the next page, I want to put all this information on a graph. So do me a favor. Plot the point negative 3, 0, 1, 0, 0, 3. Where did I write the vertex? Right here, negative 1, 4. Plot all of those on the xy axis and then we'll take a look. And here we go. I've moved all that information. Remember our vertex right here was at negative 1, 4. That's this point. I had a y-intercept of 0, 3. Had an x-intercept of 1, 0 and another one of negative 3, 0. And you don't have to label all those, but I wanted you to see that. Okay, I just moved them over. Now, that's enough. Remember, that's the vertex. So and my graph opens downward, which is exactly what's happening here. And there's my parabola. Had everything I need right there. All right, my next problem, again, find the vertex, the axis of symmetry, the whole drill. It's a lot, right? So the vertex, as long as my problem is multiplied out, like it is in this particular situation, then my vertex is x is equal to negative b over 2a. Okay? So this is going to be negative 24 over 2 times 3, which is going to give me negative 24 over 6, which is negative 4. So that's my x value. How do I find my y value? I take my x value and I plug it in the function. So I'm evaluating f of negative 4. So this is 3 times negative 4 squared plus 24 times negative 4 plus 30. Now, negative 4 squared is 16. 3 times 16 is 48. 24 times negative 4 is going to be negative 84 plus 30. Feel free to use your calculator on this, which, by the way, I should have done because 24 times negative 4 is not negative 84. Let's back up just a second. So real quick, 3 times 16 is definitely 48. And why is that positive 16? Because you square the negative. 24 times negative 4 gives me negative 96 plus 30. So I'm going to type in 48 minus 96 and then plus 30. And that gives me negative 18 is my y value of the vertex. So I've got some bigger numbers on this problem. Now let's keep going and let's find the axis of symmetry. So axis of symmetry, all you need is the vertex for that. It's going to be x is equal to negative 4. So that's my axis of symmetry. Next is the Y-intercept, which again to me is the most work. That's the biggest job. So to find the Y-intercept, the X-intercept, you set y is equal to 0, and then you solve. So I have 0 equals 3x squared plus 24x plus 30. Now I do notice there's a greatest common factor of 3. I'm going to factor that out. 3 times x squared plus 8x plus 10. Now, if I could think of numbers that multiply to be 10 and add to be 8, I'd factor, but you know what? They don't exist. So that means I have to use the quadratic formula. So it's x is equal to negative, my b is 8. You can use the original one with the big old numbers, but since we factored out that 3, this would be easier. So negative 8 plus or minus the square root of 8 squared minus 4 times a is 1, c is 10, and this is all divided by 2 times 1. Let's keep going. That's negative 8 plus or minus the square root of 8 squared is 64 minus 40, and that's all over 2. So that's negative 8, don't let me lose that negative, plus or minus the square root of 24 over 2. Now keep in mind, I've got to graph this. So I can continue on with finding exact values, but it sure would help to graph if I knew what the decimal version of this. So I'm just going to find out what the decimal version of negative 8 minus the square root of 24 over 2 is, and also what is negative 8 plus the square root of 24 over 2. Okay, now careful when you type that in your calculator. That needs to be in parentheses before you divide by 2. Alright, so I got that typed in my calculator. Remember, that's my x value, and then comma 0 is my y value. So I just wrote those in point form right there. Okay, so those are my x-intercepts. Y-intercept, that's the easier, right? You plug in x is equal to 0. So that's going to give me y is equal to 3 times 0 squared plus 24 times 0 plus 30. Yeah, that just gives me 30. So that's the point 0, comma 30. That's my y-intercept. Now, what else have we not answered? How do I know that this shape is a parabola? Because of the x squared. If your highest power is x squared, then it is a parabola. How do I know if it opens upward or downward? It opens upward because of the positive 3 times the x squared. If that were negative 3x squared, it would open downward. All right, now let's see if we can take all this information and put it on a graph. Well, first let me point out the xy axis I have is not going to work out, right? So this 10 right here, look what I'm going to do. I'm going to cheat and I'm going to make that a 30 because we needed a 30. So this is 30, which means halfway, that's 15. So this is negative 15 right here. This is negative 30. I'm going to keep my x the way that it is, and then let's just do the best we can with what we have. Okay, so I plotted the points the best I could. 0, 30 was your y-intercept. This was negative 6.45 as an x-intercept, negative 1.55 as an x-intercept, and this was my vertex, which is negative 4, negative 18. Again, I just guesstimated the best I could. Remember, this parabola was opened upward because of the positive 3 in front here, and that's exactly what ours does. And there's a pretty decent looking graph of that thing. Yours probably looks better. Again, I just threw the scale up here, not thinking about these could possibly be much bigger. Alright, now this problem is in a different form. Notice this is in standard form, and so using x is equal to negative b over 2a would only work if we multiply all this out. So we would have to square the x minus 5, do an x minus 5 times x minus 5, and distribute the negative 4. Let's don't do that. When it's in this form, the vertex is the opposite sign of what's in the parentheses, so positive 5, and you keep the sign out. There's my vertex, 5, 2. My axis of symmetry is x equals 5, so that's always easy as long as you have the vertex. Now my x-intercepts, remember what you do is you set the whole function equal to 0. Now if you want to, once again, you can multiply all that out, but I have a trick. When it's in this form, I say a trick. It's just doing algebra to solve it. So subtract the 2 over. So I have negative 2 equals negative 4x minus 5 squared. The next thing I'm going to do is divide both sides by negative 4 to get the x minus 5 squared by itself. That gives me a positive 1/2 on the left and x minus 5 squared on the right. I have to take the square root of both sides. But y'all, when I do that, I have to have a plus or minus in front of the non-x side so that square roots cancel. And now I have plus or minus the square root of 1/2 is equal to x minus 5. The last step to solve for x is add 5 and add 5. So I get a weird answer. I get x is equal to 5 plus or minus the square root of 1/2. Is that okay? Yeah. Remember, we're just trying to graph. So we can type that in our calculator. Notice that you'll need parentheses around that 1/2 because you're taking that entire square root. So I'm going to type that in my calculator. Okay, folks, when I unplug this in my calculator, when I did 5 minus a square root of parentheses 1/2 equals, I got 4.29. And then 5 plus the square root of 1/2 is 5.71. Now, we write this as an ordered pair. Remember, our y value is 0. So those are my x-intercepts. The y-intercept, remember, is when you let x equal 0. So y equals, going right back to the original, negative 4, that's 0 minus 5 squared plus 2. That's negative 4. Now, negative 5 squared is 25 plus 2. Negative 4 times 25 is negative 100 plus 2. That gives me negative 98. In point form, that's negative 98, comma, 0. No, it's not, because that was my y value. Let me back up. How about 0, negative 98? There we go. Now, that xy axis that I gave you on this one's not going to work out all that snazzy either. So let me flip over there and let's make some adjustments, because if I want to get my y-intercept on there, I've got to go all the way down to negative 100. So I'm going to scale everything by 10. So let's take a look. Instead of being 10, that's going to be 100. That's going to be 50. That's going to be negative 50, negative 100. My x's I'm going to keep just as they are. Okay? All right, now let's move this information over. Now this wasn't an easy one, was it? So we have the vertex, which was, what was it, 5, let me go back. It was 5, 2. So when I flip back over here and you take a look, the vertex 5, 2, I went 5 and I just barely went above the x-axis because remember 50 is right here. So 5, 2 is just barely above the x-axis. Then my x-intercepts, let's go back and look at those guys. We have 4.290, 5.710. Now I had them both there, but one disappeared. So here's about 4.290, here's about 5.710. And then my y-intercept is down here at 0, negative 98. And there he is. Now, we didn't say, but you know what? This parabola opens downward. Why do I know? Because the negative 4 in the front, that's your A value. When your A is negative, then you open downward. And so this is what we're dealing with. And as long as you have at least 3 points plotted and connect the dots, then we're good. So we've got 2 more of these problems. Again, we're supposed to find the vertex, and this one's all multiplied out. So, you know, our x equals negative b over 2a situation works just fine here. But you know what? We don't have a b. Does that mean we can't do it? That means our b is 0. So it's negative 0 over 2 times 1, which is 0. So our x value over vertex 0. What's the y value? Remember, you take 0 and plug it into the function. So g of 0 is 0 squared plus 4. That gives me 4. So there's my vertex. My axis of symmetry is always x equals the x value of the vertex, so x equals 0. Next thing I want to do is calculate the x-intercepts. So x-intercepts are always calculated by letting y equal to 0. So I say 0 equals x squared plus 4 and solve that equation. You could use the quadratic formula. You could use the square root property in this case by subtracting 4 over. If you take the square root of both sides, you'd have plus or minus the square root of negative 4, which you know that's plus or minus 2i. But you know what? That's imaginary. If you get imaginary x-intercepts, there are no x-intercepts. We don't have imaginary values on a real xy axis. So no x-intercepts. What about y-intercept? That's, remember, when you set the x value equal to 0. So if x is equal to 0, that's going to give me y is equal to 0 squared plus 4, which is 4. So that's the point 0, 4. Now, does this parabola open upward or downward? It opens upward because there's a positive 1 in front of that x squared. That's your a value. All right, did we answer everything? Yes. Now let's put all that information on an xy axis. This will be a little easier to graph than the last two. So remember we had, I can't remember any of it. We had a y-intercept of 0, 4. That was my y-intercept. I didn't have any x-intercepts, so I can't plot those. What was my vertex? Remember, negative b over 2a was 0, 4. Look, that's the only point I have. That means I can't graph my parabola, right? Well, no. No, it doesn't, because this is exactly why you learn how to do a t-table. Y equals x squared plus 4. What should you plug in? I say a point on each side of that vertex right there. So let's plug in negative 1. Let's plug in positive 1. So that would be negative 1 squared plus 4, which is 1 plus 4, which is 5. So I'm going to plot the point negative 1, 5. And then 1 would be 1 squared plus 4, which was 1 plus 4, which is 5. So I plot the point 1, 5. I connect the dots, and then I have a happy parabola. How do I know this was a parabola to start with? Because of the x squared. Anytime you have x to a variable to an exponent, and the highest exponent is squared, then you have a parabola shape. One more practice problem. So this is our last problem. Notice this is in standard form. Whenever you have your parentheses and the square on the outside, that's just standard form. You're thinking you're missing plus or whatever, but you could say that's plus 0 out there. So that means your vertex, remember, it's always the opposite of what's inside. So negative 4, the same as what's outside, 0. Or you can multiply x plus 4 times x plus 4, and that would give you x squared plus 8x plus 16, and then you could do the negative b over 2a stuff, and you would still get negative 4 or 0. Your axis of symmetry is always x equals the x value of the vertex, so x equals negative 4. The x equals part's required, y'all. What about the x-intercepts? So to find x-intercepts, you let y equal 0, so that's 0 equals x plus 4 squared. I'll solve that equation by taking the square root of both sides, right? So plus or minus the square root of 0 is equal to x plus 4. Well, y'all, square root of 0 is 0, so 0 equals x plus 4. Subtract the 4 over, x equals negative 4. In point form, that's negative 4 comma 0. That is my x-intercept. What about the y-intercept? So y-intercept is when you let x equal to 0. So that's going to be y is equal to 0 plus 4 squared. That's going to give me 16, right? 0 plus 4 is 4. 4 squared is 16. That's the point 0, 16. So again, my xy axis that I gave you is not going to be perfect. Let's fix it a little bit and then plot these points and see what happens. By the way, does this open upward or downward? Well, we know it opens upward because there's a 1 in front of this x plus 4 squared. Or if you looked at it here, there's a 1 right there. Positives open upwards, negatives open downwards. So this opens upward. All right, let's fix our XY axis and then plot points. So here's my XY axis, and remember I needed 16, and it only goes to 10. Oh, let's just leave it like it is and plot our points and put 16 up here. How about that? So I'm going to plot the points negative 4, 0. I got another negative 4, 0, and 0, 16, and that's all I've got. Okay, so negative 4, 0, and then 0 again. If that's 5, then 16 would be about right there. Okay, now we said this open upward. Now one thing we know is that 4 to the right of our vertex, it's up at 16. So you know what? 4 to the left, it's also up at 16 because it's symmetric. 1, 2, 3, 4. It's up at 16. But you could also plot a point, like if you wanted to, you could plug in negative 3 and see what you get. So negative 3 plus 4 squared would be 1 squared, which is 1. So negative 3, 1 would be on the graph, which also means negative 5 1s on the graph. And now we have lots of points. And there you go. I hope this was helpful. Have a good day.